is okay. Can you see the presentation, please?
Okay. Basile, can you talk before the presentation a little bit of your lab?
Yeah, of course. Okay, thank you. I will do a little introduction. Okay, I'm ready about this. First of all, I would like to thank you, Max, for your invitation to talk about the research we are doing in our laboratory. And of course, it's so exciting, okay, to talk in front of so many members. And it was really my pleasure to join this club. Here we are. Thessaloniki is the name of the city where I'm living, where the Aristotle University is located. Also later some picture from our lab. We have organized a nice wet room with media aquarium inside, where we can keep seawater. We can expose marine organisms over there, especially fish and mussels. And we are doing experiments regarding their adaptation to changes of environmental changes. I'm going to talk about the mussels, the effect of elevated temperature on the mussels, Metabolic and on the land snails, several species. As I told earlier, our research is focused on the ecophysiology and adaptation of mussels, fish, and land snails to environmental changes. And more specifically, is focused on the molecular and metabolic responses to thermal stress. The latter is related mostly to global warming in the context of climate change. A parenthesis, I don't know whether you can hear me well or not, if the sound is okay. Marcelo?
Yes, the volume is okay. The sound is good.
Okay, thanks a lot. Well, we know that almost, and it's a report of CCP, we have an increase of global mean temperature by 1 point, just a moment, 1.0, okay, sorry, 5 degrees Celsius. But according to several climatic projections, it's expected further increase in the mean global temperature, either in the land or in oceans. So it is very important to explore the adaptive mechanism of land and marine organisms to thermal stress. Moreover, it's important to determine the thermal limits of tolerance, because they can help us to predict how global warming will impact several species over the world. I can say that in this context, physiologists are based on the curve of physiological performance in order to figure out when stress responses are triggered under thermal adaptation. It's well known that each species exhibited the optimum, the maximum physiological performance within a range of temperatures. Temperature values means from Latin pessimus, worst. So the left and right of the zone, we have the zone of stress. And of course, we have the critical temperatures where the organization of metabolism, shift of aerobic to anaerobic component of metabolism, oxidative stress, and apoptosis. So it is very important to determine, to know what is this point beyond we have all these stress responses. Of course, it isn't so easy. It's a complicated topic. Since we have fault-tolerant, warm-tolerant specialist and generalist species. I can say that this curve, physiological performance, is based mostly on this law, on the sulfur law of tolerance, who said that the abundance of individuals are found in a specific range of temperatures, and they try to avoid the zones left and right, which are the stress zones. It is believed that global warming will narrow this optimum zone, and will widen the zone of stress. Some people saw in the future, we expect that species will be exposed longer to elevated temperatures. Some scientists characterize this optimal range as the Aristotle's golden mean, who said that virtue is the desirable middle between two extremes, one excess and the other deficiency. Today, there are several tools of molecular biology, the omics, which can help us to understand when we have cellular stress responses. We know that the deviation from optima, deviation of levels of factors, environmental factors, from their optima, pH, hypoxia, etc., induce the gene expression, and we can increase the corresponding mRNAs. We can characterize this step as preparatory strategy. So it starts to prepare to defend more stressful conditions. However, the translation of mRNAs into proteins is dependent on the magnitude and the duration of stress beyond the threshold level. Then we have changes to the level of proteins, and of course, the structural and functional changes. Thereafter, we have the organization of several metabolic pathways and accumulation of several metabolites which may be indicators of anaerobiosis, energy balance, apoptosis, oxidative stress, inflammation. But recently, there is a topic very interesting, that of osmolytes, and there are several works who reported that under thermal stress, and specific particular group of metabolites of organic compounds are accumulated, and this is osmolytes. They have many members of this group have a strong antioxidant effect. It is believed that this group is another mechanism for antioxidant defense and non-enzymatic antioxidant mechanism. Overall, and we know it very well, the experimental procedures applied under laboratory conditions do not always reflect what is happening under natural conditions in the field. For example, the experimental designs and the procedures in the lab help us to adjust the levels of any parameters of interest and to study its impact on the physiology of marine organisms. However, the field is a scenario of several factors, including temperature, salinity, parasites, ocean acidification. We believe that by integrating data obtained from both experimental procedures help us to answer the question, are individual species seasonally stressed under field conditions? So, following this principle, we are doing experiments in our lab. As I told earlier, we have a very good, nice, wet lab with many tanks filled with seawater. Of course, we have the circulating RAS system here, circulated seawater, and we can test how several parameters impact the physiology of species, either fish or mussels. Regarding now to field studies, we are sampling seasonally species individuals from some farms, fish farm and mussel farms. The advantage of this is that the individuals cannot avoid the stressful conditions. So it helps us to study seasonally whether they are impacted or not of the same species at different altitudes. That inhabit in high altitude are facing during winter temperatures below zero, -10, etc., and lower summer temperatures than those inhabited zero level. Accordingly, they are good models to examine whether they exhibit different adaptive strategies. Now, regarding recently, we studied the oxidative stress and the heat shock responses in different land snail species or population of the same species in a latitudinal gradient from north to south degrees. The areas at north places are characterized by higher humidity and lower temperatures than those in the south degrees. Again, they are very good models to study their adaptation in a latitudinal gradient. Below, I'm going to present some data we have almost published regarding to the above studies and giving some evidence no mortality. In the experiment, we set up a system for reporting the time of valve closure opening during under the same protocol, experimental protocols. The reports showed that when we have an exposure at 24 degrees, the mussels keep themselves in the valves higher time than they keep open. But the opposite happens when they are exposed to temperatures beyond 26 degrees Celsius. The latter indicates oxygen and nutrients supply, which means a higher need for energy turnover, probably to defend the thermal threats. Then the data, the results, showed that during exposure to 24 degrees Celsius, glycogen is oxidized towards an aerobic end product succinate. This metabolic pathway is characterized by strong metabolic depression and low rate of ATP synthesis. However, at the temperatures beyond 26, we observe a reactivation of metabolic rate. And of course, we have an increase in the synthesis of ATP synthesis. The latter coincides with the time course of heat shock protein synthesis accumulation, since it is an energy-demanding process. But a further analysis of our results showed that before muscles enter hypometabolic, there is an initial period. Because we observe synthesis, metabolism, growth, etc. And the data showed that this ratio peaked at within the first 5 days of exposure at all treatments. Even more, and I think that's the most important finding, we observed initiation of gene expression at 22 degrees Celsius, earlier lower than 24 degrees. In temperature that does not cause mortality in the mussels. Some report that it means that the organism may have a system of thermal sensing and they start preparing to defend more stressful conditions. And of course, it was observed for the tissue protein 70, 90, and for the antioxidant enzyme so. But the same about the results we obtained, even for catalase, glutathione, transferase, and the metaproteins. And I can say that really it is a very strong indicator about the post-study, which means that mussels start preparing to defend thermal threats later. And this data, of course, here are supported by the enzymatic activities of the corresponding antioxidant enzymes, and we can see increase in enzymatic activities at all enzyme temperatures, either under metabolism or during metabolic reactivation. The same for catalase, the same pattern of changes, and the same pattern of changes for glutathione reductase. Finally, we integrated all this data with other published earlier into a model. This model support indicates that probably there is an interplay between the pattern of metabolism, the accumulation of ROS, and the other intracellular factors, including energy turnover, probably decrease in the cellular case, which seems to factor in a synergistic way phosphorylated several members of kinases and then activated several translation factors, and finally we have a reduction of genes related to antioxidant enzymes and sheets of proteins. These data have been published almost in American Journal of Physiology, and these are available for anybody. Now, regarding to longitudinal studies on the blood snails, the data showed a sudden increase in the activity of salt within the first 10-15 days of exposure to elevated temperature, about 33 degrees Celsius, which is the mean summer temperature in Greece. And it indicates a fast antioxidant effect during this period, the first one. Thereafter, salt activity either dropped at the control levels or remained at high levels. The same about the response observed for catalase. Its activity increased sharply within the first 10 days, but thereafter it dropped at control levels at all species, from the species from the north to south. And the same response within the first days we observed for glutathione reductase, within an increase and a significant increase in its activity within the first 10-15 days. But in contrast to catalase, its activity remained at high levels. Even more, we observed a further increase during long-term festivation. Of course, we're still analyzing this data, but so far, our analysis, statistical analysis, show that difference among and within species in the intensity in which stress proteins are induced. Probably they could be associated with hypothalamus, that they could be associated with a large snail's ability to survive adverse environmental conditions and persist in stressful habitats. We believe that there is an interplay between glycolysis and the redox balance during hypometabolism, and probably a shift from NADH to NADPH producing metabolic pathways. And these data are in line with those published earlier, either from Marcello, from Storey, and their colleagues, and they have been discussed extensively. And probably this is supported the physiological role of this reorganization during long-term observation is the maintenance of this ratio, which is very important for long-term antioxidant defense during starvation. As I have mentioned above, muscles show an initial period of increase in the energy turnover before enter hypometabolism, as we can see here. But the similar pattern we observe in the snails as well. As we can see, the level of ATP increased the first 5 days before enter hypometabolism. And we believe that is very important, is needed since the synthesis of antioxidant enzymes and heat proteins needs energy, but the synthesis is a high energy demanded process. Regarding now to attitudinal studies, we observe phenotypic plasticity and the differences between the warm and the cold adapted snails. As you can see, the levels of heat shock protein 70 remain during all seasons at about the same levels. However, the contrary, there was a sudden increase in this level in the cold adapted snails within the first period of arousal, and later they remain stable about levels. For me, it's really very strong evidence about the post strategy. But when they indicate that probably the warm adapted snails individuals maintain high levels, constitutive levels of heat shock proteins during all the year. And this assumption was supported further when we transplanted reciprocally individuals from high altitude to low altitude. And as we can see here, after we observe that the levels of heat shock protein remain at high levels, heat shock protein remain at high levels compared to controls. And really is very strong support about this hypothesis. The hypothesis which supports that ectotherms occupying extreme environments use a preparative defense strategy involving in the maintenance of high heat shock proteins constitutive levels, thus allowing an immediate response to potentially damaging effect of heat stress. So, of course, any defense, any preparation is, I believe, is energy. And an early field experiment on Olympus Mountain on another land snail species in the Catania zona olympica, which is living at 1,100 meter altitude in Olympus Mountain, we observe that the enzymatic activities of glycolytic enzymes start increasing even during the period of arousal. We have measured several enzymes, but here I'm showing only the DLTase, lactate dehydrogenase, and the tracicase, which is very important enzyme for website. Now I'm coming another topic that really found a lot in this research in many species. And this topic is of organic cosmolites, and there are several members. Some of them have been studied extensively. There are several reports about their antioxidant effect, especially taurine, betaine, and TMAO. And we made some experiments regarding to see what is happening when muscles are stressed, thermally stressed, and we examined whether these compounds are accumulated. And we applied a principle that of Hartenin. Hartenin is probably is a rapid beneficial response during brief exposure to sublingual temperature that occurs within hours or as opposed to acclimation which take days. When exposed to mild stress, cells, organisms respond by a variety of adaptive cellular programs that prepare preconditioned state. And when an intense stress is applied subsequently, preconditioned but not naive self-organisms exhibit stress resistance and eventually improve survival. The term hormesis comes from the Greek hormesis and is the same root for the word hormone. This concept, the hormesis, now is found application in many research areas, areas of research. We can see even for environmental sciences, medicine, pharmacology, toxicology, etc. And this is the most important. Less can be more. How we can apply some condition so to make more strong some organism to defend stressful conditions. Well, following this principle, we made a cyclic exposure of mussels to sublethal temperature and control temperature, 18-27, for 4 days. Thereafter, both groups acclimated for several days at elevated temperature from 18 to 80 degrees Celsius. And regularly we make samples and we determine several parameters. But I'm showing some of them here. All this data have been published in a scientific report. Well, we observed that there was a marked significant increase in the gene expression in the catalase. And not only in expression, but in the activity as well, compared to non-hearted mussels at all treatments. The same about pattern of change of gene expression was observed for glutathione reductase and glutathione transferase and the activity of glutathione reductase, which means that hardening the muscles can have a memory after this procedure, which make them more resistant to thermal stress. Recently, we determined by applying methods, the increase the levels of several metabolites, and we observed that many of these osmolytes are really accumulated during thermal stress in muscles when we apply this principle, this method of hormesis. I can say that after thinking about analyzing all this data, that probably we have two phases. At least we can suggest two phases. The phase one, when we have an energetic preparation, we need energy for the protein synthesis, for the translation of the genes, for increase of proteins. So since we have this phase, then we have the preparation to the phase of oxidative stress, which means, however, this phase is characterized by metabolic depression. So based on obtained data, we can suggest that metabolic reorganization may govern in a great extent the enzymatic and the non-enzymatic mechanism of antioxidant defense. However, we need further research to explore the mechanisms that are involved in the thermotolerance of species and their sensitivity to thermal stress in the context of global warming. I would like to thank you for your attention, and I would like to take the chance. How can I? You want me to keep this state in the presentation or to leave the full presentation? Marcelo?
Oh, hi. I was trying to reestablish the microphone. Oh, thank you for your presentation. How we go back to see everyone? Oh, yeah. Okay.
No, before start the questions.
Oh, Ken Story. Yeah, thank you. Yeah. Thank you, Basile, for your presentation. Okay, give you
Really, it is for me.
A lot of data. So I'd like to open for questions.
If you please, let me say something. Sorry.
Yeah, I would like to thank you for your presentation, and I really like this proposal of this energetic pre-adaptation. It's really interesting because it is something that we have been discussing for a long time. So how come these animals are able to induce this preparation for oxidative stress if they have the metabolism at low pace? At slow speed. So it's this idea of increasing ATP at the very beginning. It's very interesting. Very interesting. It's first time I heard about this idea.
Marcelo, before I would like to say something. It isn't so easy for me. I'm sorry.
Pardon me?
Before your questions, and I would like to say something.
Okay, please.
If you please.
Yeah, please.
Because I'm retired after 2 months, but I would like to thank someone who helped me a lot, who introduced me in this person. And I like to thank Ken Story. Really helped me a lot to understand what's happening with the metabolic depression, how we can work on the metabolic depression, and how significant is this section in understanding how several species are adapted to environmental changes. Many thanks.
When he was a very small boy, he came to my lab, and he was excellent, and he's grown so much so far. He's outstripped the old guy who is now me. I used to be young like he is, and he was even younger, and now I'm old. So that was really actually made a huge number of strides. A number of people came to my lab early on in their careers, including Marcelo, bless his heart, and then outstripped me, then just went and created this entire field. So I'm the grandpa somewhere in a chair. You guys are the young guns and then the older guns. Thank you.
Yeah, we all thank you, Ken. We all love you.
Really. Okay. I don't know whether there is a question.
I just wanted you to comment more about this energetic pre-adaptation. I never heard about this. It's very nice. It fits everything. It's incredible. You presented so many data that at the end I was kind of a headache. There was so many data I had to process in my brain. It was kind of hard. But this I got really I got really interested with this proposal. It's really important.
There are so many data, but just I'm trying. I don't know if I have managed to do that, but I'm trying to underline the most important concepts about the adaptation. Okay, several species. So that's why I presented some of them.
Yeah, of course. So much data. Yeah. I was wondering if you could have done some experiments elsewhere in higher mountains, because you don't get much high in Greece. Yeah, it's like 1,000 meters. It's the maximum.
No, there are species even higher at 20,000. Okay, but it isn't so easy for us to get at these places. because there
Okay.
are no roads, okay? And unfortunately, we aren't well equipped to do such samples.
Yeah, but these experiments are very interesting because you know it's a kind of, it's what we call the field experiment, that you place the animals in the cages and they are in the environment, but they are not, you know, all over the place. They're in where you can find easy and then they dissect them. It's a very good strategy.
But,
so let's open for other people to ask questions, please. Please, there are so many people. So we are opening for questions, everybody, please.
But I'm sorry, but I have to point out that my experience, according to my experience, in order to understand better what's happening about adaptation, we need long-term experiments.
Yeah.
And not only acute exposures. Because of that species have the ability of acclimation, compensation, and many responses are masked after 1 month or 2 months. So it's very important to perform long-term experiments and to do samplings regularly at first days, after 2 days, after 3 days, etc.
Yeah, that's what you did. Many of your experiments have many time points. It's a big problem in the field because people, they have control and one stress condition, maybe two, and that's it. Maybe 2 hours, 12 hours, and that's it. So it limits how we understand the phenomena, especially on the laboratory. The experiments done only in the lab. There is a question from Alexandra. Every animal. Can you answer, Basile?
I'm sorry, but I can hear.
You have to open the box for text. That text.
It's in the
Thank
chat.
you very much for your point of view. Every animal responds to short time heat shock by reactivation of antioxidant capacity. I mean, your data about short time exposure of mussels to high temperature. She said it's common to all bivalves, for example.
Sorry if you understand well, the question is about the antioxidant responses during the first days, during the first hours, during the, I don't know, sorry.
Can you see the
I can
question?
see the question written somewhere.
Did you read the question?
Where can I read this question? Is it somewhere in the chat?
In the text.
Basile, in the top of the screen, have the chat. You can click in the chat and you will see.
Yeah. Okay. Okay, thanks a lot. Okay. Sorry, the question from Alexandra, okay, from your point of view, every animal responds to short time heat shock by the activation of antioxidant. Emily, your data about short explore on muscle to high temperature. I can answer this question, okay? We determine the enzymatic activities, but I think antioxidant capacity isn't only increasing antioxidant activity of antioxidant enzymes. There are so many factors we don't know yet how they work in the cells that defend the accumulation or eliminate the loss. Okay. But I think for me it's complicated. So we need more data in order to answer all of these questions. even a short or long-term stipation, hibernation, etc. There is a delay to sound, Marcelo.
Oh, she says thanks. Okay, more questions, people. What do you mean, hawk elida?
Campos question what happens with hawk. Okay, we have no such data.
Or GPX.
Yeah, unfortunately, we have not yet such data because recently we start working on gene expression of the oxidant enzymes, and we are going to analyze what's happening about this.
Okay. A question by Bill Wilmore. Taurine, beta-in, TMAO.
Just I'm reading William's question about taurine, methane, TMAO, sorry. Yeah, really, it's very, for me, interesting topic. And we started working on this during the last 2 years. Now we are going to analyze more data regarding these metabolites. But unfortunately, we have data only for the mussels. And we are going to extend these studies in other species, for example, in land snails. And we'd like to know, and they probably can help us, how these compounds are involved in during hibernation, keeping cells alive under zero temperatures. We don't know yet. But we are about to start working on this topic.
Okay. More questions? I would like to ask you a question. Have you wondered what if you could try to use some inhibitors of antioxidants, for example, aminotriazole injection or ESO, to modulate your responses?
I don't know how the methodology to apply such inhibitors. Okay, since we're working on the full organism. Okay, for example, we are sampling snails from the field. So how we can apply such inhibitors? Probably we can do that under laboratory conditions, incorporating some inhibitors into their food. But by now we are using natural food, lettuce, for example. So to keep state, to simulate some conditions as that found in the field, not to say it's everything. Okay, but that's a good question. I don't know. I know that some people applied some inhibitors in the mussels, since you can add diluted some inhibitors in the seawater, and these inhibitors are absorbed from the cells, from the mussels, so we can see probably whether they have an antioxidant or inhibit the oxidative capacity. But we've never tried such inhibitors so far.
Okay, thank you. Yeah, we did some work with BSO in mussels, in snails. Sorry, in snails, and it was a very small effect. We just published this. The snail has a very potent antioxidant system. You depress glutathione by 70%, and very little things happen with the animal. It's incredible.
Okay.
Okay. More questions? Marina, is the system works for more than 1 hour, or it's still working? Just 1 hour after. So, are there more questions? Oh, so I'd like to thank you. I think there's no more questions. I'd like to thank you very much, Basile. This is our very first meeting in this club. I would like if everybody could open the camera so we take a picture of all of us. It would be nice, for our first meeting. So if you're...
thank you for your attention, really. So I was a little bit nervous. It was my first
yeah, that's okay.
Before so many people, members, and especially in front of my previous supervisor, Ken Story.
Yeah. So when did you work with Ken? When?
It was about 38 years ago. 38 years ago.
28. Yeah. 28 years ago.
Yeah.
I had really the best experience.
Marcelo also visited our lab many years ago, and our lab is almost back to normal from Marcelo's visit. We've almost gotten all of the Brazilian out of the rooms. Almost.
I'm taking this chance to send my best regards to your Susanna, your wife. She was so polite to me, really.
Okay, so we will arrange to have a second meeting. I will talk to people to see which one we would like to give our second talk for our club, and we hope to keep going. And thank you, Dr. Neil, to be here. It's very nice to have your presence. Yeah.
Thank you.
So you probably will be on our list for a talk very soon. So we have to learn about your turtles, your lovely turtles. Yeah.
Hello.
Hi, Ken.
Okay. Bye bye.
Thank you for it. Thank you a lot.
Bye. See you next. See you, Ken. Nice to see you, Ken.
Me too.
Yeah.
Thank you.